Welcome to a new deep dive. Today we're unraveling the fascinating story of .NET. For years, the landscape of Microsoft's development platform, it felt like navigating a bit of a maze, right? Different frameworks, different paths. Our mission today is to cut through that complexity, tracing .NET's incredible journey from its roots in .NET Core to the unified powerhouse it is now, and hopefully arm you with the crucial insights you need to understand where it stands today.
It's truly a story of, well, strategic evolution and, frankly, a massive cultural shift for Microsoft, too.
Yeah, that shift is key.
From its origins as a bold move to modernize and expand the reach of their traditional .NET framework, to becoming this single comprehensive platform that can build almost any kind of application across, the entire operating system spectrum.
Okay.
So yeah, we'll peel back the layers to understand what makes it tick, the immense range of applications you can build with it, and yes, even navigate some of the more maybe surprising twists in its history, especially around that whole open source pivot.
That open source pivot is where it gets really interesting for me. When I first heard about .NET Core, I admit I was a little skeptical. About Microsoft truly embracing open source and cross-platform development.
Yeah.
How significant was that shift, really? Especially for developers who had built entire careers on the Windows-only framework.
That's a perceptive question because, yeah, one of the most surprising twists in .NET's history wasn't just technical. It was a profound philosophical leap for Microsoft. Historically, they were known for their, let's say, tightly controlled, closed-source approach.
Right, very much so.
The introduction of .NET Core was a deliberate and honestly pretty radical move into the open-source world. This meant more than just, making the code public. It required building trust with a frankly skeptical developer community, transparency, collaboration.
Building bridges.
Exactly. And critically, it also introduced true cross-platform compatibility, allowing developers to build apps that could run natively on Windows, Mac OS, and Linux, which was just a game changer for so many people.
So it really started as this distinct thing, .NET Core. But then the naming strategy seemed to shift, which I think caused some confusion in the community. What was the thinking behind bringing everything under one umbrella, started with .NET 5?
Precisely. You had the original .NET framework, mature, powerful, but very Windows-specific.
Yeah, the classic one.
Then you had .NET Core, the agile, cross-platform, open-source future. Over time, Microsoft realized having two distinct .NETs was, well, fragmenting the ecosystem. It was confusing for developers.
I can see that. Which one do I choose?
Exactly. So the unification, beginning with .NET 5, was designed to consolidate these two paths into a single, comprehensive platform. They essentially said, look, this is just .NET now.
Okay, simplifying the message.
Right. And subsequent versions like .NET 6, which is a long-term support, or LTS release.
Ah, yeah, the LTS versions are important for stability.
Very important. Means it's maintained for several years, offering stability for large projects. And then the more recent .NET 8. They've all solidified this single, unified platform for all application types, really aiming to simplify choices and the whole development experience.
Okay, let's unpack the core mechanics then. What are the foundational pieces that make this unified .NET platform function? And what's going on under the hood that allows for this cross-platform magic?
Okay, so at its heart, the .NET ecosystem relies on the Common Language Runtime, or CLR.
The CLR, right?
This isn't just any runtime. It's a really sophisticated virtual machine. It manages the entire execution lifecycle of your code. Think of it as the highly optimized engine that runs your .NET applications.
Gotcha, the engine.
It provides crucial services like robust memory management. It has this advanced garbage collector.
Takes care of memory leaks and stuff.
Exactly. Ensures code safety via its type checking system, handles security checks, all fundamental to .NET's enterprise-grade stability and reliability. Now, when you write code in languages like C# or F# or even Visual Basic, it's not compiled directly to machine code.
Oh,
Instead, it's first translated into something called intermediate language, or IL.
Intermediate language, IL. Okay.
So it's compiled once into this IL, and then the CLR takes over, handling the execution across different machines.
That sounds incredibly efficient. Does that mean, say, a C# app compiled for .NET 6 on Windows will run flawlessly on a Linux machine with .NET 8 without any recompilation or, runtime differences to worry about?
That's a great follow-up. The compile once run anywhere ideal is largely true thanks to IL and the CLR, but the nuance is you need the specific .NET runtime for the target operating system installed on that machine.
Ah, okay, so the runtime needs to be there.
Right. The CLR on that machine then efficiently executes that IL code, often using just-in-time or JIT compilation.
The JIT compiler. Heard of that.
Yeah. The JIT compiler translates the IL into native machine code at runtime, specifically for the computer it's running on right then. This is where a lot of .NET's performance comes from, especially with newer features like tiered compilation.
Tiered compilation. What's that?
It's clever. The JIT can initially prioritize quick startup, compiling code quickly but maybe not fully optimized. Then later, it can recompile the heavily used parts of the code, optimizing them much more aggressively for maximum performance.
Oh, that's smart. So it adapts.
Exactly. It gives developers kind of the best of both worlds, fast startup and high long-term performance. And complementing the CLR, there's this vast collection of pre-built code. It's known as the Framework Class Library, or FCL. Sometimes people call it the Base Class Library, BCL too.
SCL. Got it. Like at a big toolbox.
Precisely. But more than just a toolbox, it's a really meticulously designed foundation. It accelerates development hugely by providing standardized, optimized components for virtually every common programming task. File I/O, network stuff, data structures.
So you don't have to reinvent the wheel constantly.
You got it. Reduces effort and fosters consistency across applications.
And when we talk about languages, C# is often the first one people think of, but you mentioned others. The platform supports more, right? What makes C# so sort of central to the .NET experience?
You're right. It's fundamentally about language independence. While C# is, often highlighted as the primary language, developers really do have the flexibility to choose. F# is great for functional programming styles. Visual Basic is still there for those who prefer its syntax.
Okay.
C# itself is just a very modern, object-oriented, and importantly, type-safe language. Its design emphasizes simplicity, robustness, and performance. That strong type safety, for instance, which the CLR checks.
That helps catch errors early.
Exactly. It prevents many common errors and vulnerabilities right at compile time or runtime, which is crucial for building reliable, secure applications. And its efficiency is boosted massively by that JIT compilation and the CLR's memory management we talked about. Makes it excellent for high-performance needs.
Okay, so beyond these foundational pieces, the CLR, FCL, the languages, what are the tangible benefits? Why has .NET remained such a compelling and, well, popular choice for developers, especially in, say, the enterprise space?
The advantages are pretty compelling, yeah. And they go beyond just the technical elegance. Firstly, .NET is inherently designed for high performance and scalability.
Performance is always key.
Absolutely. It's exceptionally well suited for building applications that need to handle increased traffic, increased demand over time, think robust backend services, high throughput APIs, microservices, that kind of thing.
Right.
This efficiency often comes from its modular architecture, the built-in asynchronous programming models, and those low-level optimizations in the CLR and JIT compiler. In scenarios needing intense CPU work or complex multi-threading, .NET often really shines, sometimes even outperforming alternatives in those specific areas.
And for anyone concerned about keeping their applications secure, which is, let's face it, paramount today.
Absolutely critical, and security is deeply embedded within .NET. It provides robust security features built right into the framework itself.
Like what specifically?
We're talking comprehensive authentication and authorization mechanisms, fine-grained role-based access control, RBAC, plus native support for industry-standard security protocols, encryption techniques. These features are designed to help protect data and applications from a whole array of common threats. SQL injection, cross-site scripting, the usual suspects, makes it a reliable choice for sensitive data.
It sounds like a very supportive and comprehensive environment for developers, not just what's built in, but the wider community too.
It truly is. .NET boasts a rich ecosystem and community support that is just vibrant and incredibly active. There's a massive wealth of third-party libraries and packages available through NuGet.
NuGet, the package manager.
That's the one. Hosting well over 300,000 packages now, I believe. Just a huge resource. And many core components are also open source, which fosters amazing collaboration and innovation directly from the developer community.
So that helps speed things up.
Definitely. All of this significantly contributes to reduced coding time. Developers can build faster, more efficiently because they aren't writing everything from scratch. Plus, for the operational side, it offers powerful manageability and continuous monitoring tools. Everything from extensive debugging and profiling inside Visual Studio to performance analysis, logging, diagnostics, and it integrates really well with cloud platforms and standard Windows monitoring tools.
Okay, so we understand the underlying mechanics, the why developers choose it. Now for the what. Knowing how .NET works under the hood and why developers are drawn to it, the logical next step is, what can you actually build with this platform? It sounds pretty broad.
Oh, the platform's versatility is truly one of its greatest strengths. You can build an astonishing range of applications across nearly every domain you can think of. For web applications, ASP.NET, especially ASP.NET Core, is the definitive framework.
Right, ASP.NET Core.
Used for creating dynamic web apps, powerful web APIs, modern microservices. And what's truly fascinating now is technologies like Blazor.
Blazor, yeah. That lets you use C# in the browser, right?
Exactly. Build interactive client-side web apps entirely using C# instead of relying solely on JavaScript. It makes full-stack C# development a real possibility for web UI.
Interesting. And what about those traditional, powerful desktop applications, the ones we often see running on Windows?
Yep, it fully supports desktop application development for Windows. Technologies like Windows Presentation Foundation, or WPF,
WPF.
are still widely used for building really feature-rich user interfaces, powerful data binding capabilities, great for complex line-of-business apps. Windows Forms is also still an option, maybe for simpler, faster application development on Windows.
And mobile, cross-platform.
Yeah, so Xamarin was the big player there for a while, provided tools for iOS, Android, macOS development using C#, letting you share a lot of code. Its successor is .NET Multi-Platform App UI, or .NET MUI.
.NET MAUI, right, heard of that.
That continues the cross-platform mobile and now desktop development effort, aiming for a more unified experience across different devices from a single code base.
Beyond the traditional web and desktop, what about newer frontiers? Cloud, gaming, maybe even machine learning.
Definitely. .NET, especially since .NET Core and the later versions, is impeccably suited for building cloud-native applications and microservices. Its performance, its modularity make it an excellent choice for services that you can easily deploy and scale on major clouds like Azure, AWS, Google Cloud.
Makes sense.
For gaming, popular game engines like Unity rely heavily on C# and .NET. Building both 2D and really immersive 3D games, countless titles are powered by it.
Wow.
And its reach extends even further into the Internet of Things, IoT, with specific libraries for device interaction, and even for machine learning tasks using frameworks like ML.NET, bringing powerful AI capabilities directly to .NET developers.
So it really is a comprehensive platform for modern software.
Absolutely. And for development itself, you've got the primary IDE, Visual Studio, which is incredibly powerful. But lots of developers also love the lightweight cross-platform Visual Studio Code. And alongside those, there's the powerful .NET CLI, the command line interface for scripting and automation.
Now, a point that often raises questions, and maybe some debate, for developers diving into .NET, is the sheer number of different UI technologies, especially on the front end, and how they've evolved. It can feel like there's been a lot of churn, maybe, and some of the community labels for these technologies can be, well, quite blunt.
Yeah, this raises a really important question. How do you, as a developer, navigate this constantly evolving landscape, particularly around UI? Historically, Microsoft offered various web UI approaches, ASP.NET Web Forms, for instance, that tried to abstract web development into more of a desktop-like event model.
Right, I remember Web Forms. Drag and drop controls.
Kind of, yeah. Then ASP.NET MVC offered a clearer separation of concerns, better for robust web apps. And ASP.NET Web Pages was designed for simpler scripting scenarios. While foundational, they are often considered, legacy for new development now.
Legacy meaning probably don't start a new project with them.
Generally, yeah. Their architectural approaches don't align as well with modern web paradigms or .NET's cross-platform goals. Similarly, WCF, Windows Communication Foundation.
WCF, use that a bit. For services.
Right. It was a robust framework for building distributed services, but it's largely been superseded by modern, more lightweight web API approaches, things like REST and gRPC.
Okay, so understanding that history is key for context, but maybe not getting bogged down in every older technology. But what about the more recent attempts on the desktop and cross-platform side? You mentioned UWP and MAUI. I've definitely heard descriptions like dead or rough applied to those. What's the story there?
That's right, and it really points to the broader challenges of cross-platform UI development. It's hard for any framework, not just .NET. Microsoft's journey in the UI space has been particularly winding. UWP, the Universal Windows Platform. That was a really bold attempt at a unified app model for all Windows devices, desktop, mobile, Xbox.
Yeah, I remember the pitch. One app everywhere.
Exactly. But it struggled with developer adoption. The ecosystem support wasn't quite there.
Yeah.
It eventually lost significant momentum. So yeah, it's largely considered dead for new strategic development by much of the community.
Okay. And MAUI? the successor to Xamarin.
Right. .NET MAUI carries the torch for cross-platform mobile and desktop using C#, but the label rough often points to, well, ongoing stability improvements are still happening. The tooling is maturing, and the component ecosystem is still evolving compared to more established platform-specific UI frameworks like native iOS Android or even WPF on Windows.
That context is incredibly helpful. So for a new project, how does someone decide which UI path to take within .NET, especially given this somewhat messy history? And maybe more importantly, what are the universal best practices, the things every .NET developer should keep in mind regardless of the specific UI choice they make?
It really means making informed choices based on the project's specific needs. For general front-end web development, especially with rich interactivity, the community often advises looking at the standard JavaScript SPA frameworks React, Angular, Vue. They integrate seamlessly with .NET backend APIs.
So use .NET for the back end, JavaScript framework for the front.
That's a very common and stable approach, yeah. However, Blazor is a powerful alternative if a C#-centric full-stack approach is really what you want. For truly native cross-platform desktop and mobile apps where C# is key, then .NET MAUI is the strategic direction for Microsoft. But developers just need to be aware of its current state of maturity and factor that into their planning. But regardless of the specific framework, web, a desktop, MAUI, Blazor, whatever, there are crucial best practices that lift any .NET application from just okay to truly excellent. When building with .NET, always design for scalability. Minimize single points of failure. Adopt a modular architecture. Think microservices sometimes. Use stateless components that are easy to scale out horizontally.
Okay, plan for growth.
Exactly. For performance, use caching effectively, whether it's in memory for raw speed or distributed caches like Redis or Ncache for scale. And really embrace asynchronous programming, async await. It's fundamental in .NET now. Oh, and for web apps, consolidate client-side assets. Bundling and minification are still super important.
And optimize delivery.
Security is paramount. Consistently validate all user input, no exceptions. Encrypt sensitive data both in transit and at rest. And rigorously protect against common attacks, the OWASP top 10 stuff like XSS, SQL injection. Know them, defend against them.
Non-negotiable.
Absolutely.
Yeah.
For maintainability, practice consistent, structured logging. It's invaluable when things go wrong. Adhere to established coding standards. The .NET community has good guidelines. And proactively refactor code, especially any auto-generated stuff. Remove unused components. Keep the code base clean.
Makes sense. Keep it tidy.
And finally, automated testing. Unit tests, integration tests, maybe even performance tests, they are non-negotiable. As is robust version control using systems like Git. These are fundamental for building reliable, collaborative, and sustainable systems over time.
So what does this all mean for you, our listener? Our deep dive into .NET reveals, well, a really powerful, free, and open source platform, one that has truly modernized and expanded its reach dramatically from its earlier days. From its core components like the CLR and FCL doing the heavy lifting, to its high performance, robust security, and that vast ecosystem. It's clearly a powerhouse for building virtually any type of application, web, desktop, mobile, cloud-native services, gaming, IoT, even machine learning solutions.
What's truly fascinating here, I think, is how a platform can undergo such a significant evolution and unification, yet still present a landscape with, diverse choices and a pretty nuanced history, especially in areas like front-end development where different approaches have emerged, faded, and converged.
Yeah, that UI story is complex.
It is, and this deep dive really shows that while .NET offers immense capabilities, particularly for those big enterprise-level high-performance tasks, the true skill for any developer lies not just in mastering one tool within this ecosystem, but in understanding the broader trends. It's about critically assessing when to fully embrace the integrated .NET ecosystem and maybe when to leverage external technologies for specific needs and constantly adapting.
Continuous learning.
Always. It really highlights the dynamic nature of the software development world, doesn't it? Constantly challenging us to learn and evolve right alongside the platforms we use.